Module 15, that will be our last module. We will go back to chapter 18 to talk about recursion. In this class, we didn't finish the whole textbook. We covered about the first half of that. So if you are interested to know more, then we will have the advanced Java you can take. So after the last module we covered, you will have your final exam. So the final exam is comprehensive. You can see the midterm exam we covered chapter 1 to 7 and 9 to 13. So then afterward we start talking about GUI. So then we have chapter 14 to 16. In the past 2 weeks, we talked about the data structure. So that's chapter 20 and 21. So we will go back to see the recursion. So that's your final exam next week will be comprehensive, including chapter 1 to 7, 9 to 16, then 18, 20, and 21. So let's finish up with our chapter 18 about the recursion. So here we were using 2 examples to talk about recursion function, but also those questions also can be resolved within the iteration. So the first thing, let's talk about what is recursion. So we will show you in factorial and Fibonacci sequence. So these 2 problems, they both can using a recursion function or a loop in a function to solve the problem. So then we will discuss when we need to use recursion, when we need to use the iteration to solve the problem. So the last one, case study, let's do the Tower of Hanoi. So we will talk about that using the recursion to solve that problem. Of course, you can think about it's possible without recursion we solve that problem. So the first thing, what is recursion? I believe many of you from the 165, you learn about recursion. Maybe in 110, we talk about a little bit. So recursion actually is the method to solve the problem. But that problem actually is not for any problem. Not all the problem can use recursion to solve for that. Because all the recursion problem, they have the similarity is the problem itself. They can be break down into a smaller, similar, and smaller sub-problem until this smallest problem is small enough that can be resolved. So that means sometimes when you see the data if the data is 100 number, certainly you don't know how to solve for that. Then we find out if we reduce by half of that, then we reduce half of that. They kind of have the similar algorithm to solve for that. So those kind of problems that we can use recursion. Because one thing is when we try to using a recursive function to solve a problem, we define a recursive function actually is a function called itself. So on the other hand, that means your big problem, the beginning when you see the whole picture, you have no idea how you will solve that in one piece. But then later on we find out if we divide into half, then we can find out actually this divide into half into 2 problems. They are actually the same as the original one. Just one thing is they still may not be solved yet. But when we try to reduce the problem a little smaller, they are in the same problem. So once we reduce into half until at the end, they may become n equal to 1 or 0. We right away see the answer. Then that we find out this problem, since they can be reduced into a similar problem. That means if I write a function for n equal to 100, so then I find out I can divide into n become half. Then this problem actually they are similar. So until reach the n equal to 1 or 0, we right away can return the value. So that means the recursion function. So recursive function actually is the function call itself, either directly or indirectly. Of course, most of the time we see that as directly. But the most important thing is not only recursion function, you call the function itself. So when you call the function itself, this part we call the recursion step. because you call your function itself. But a recursion and recursive function usually including two parts. One part you call itself, that's what we call the recursion step. And the other one is important. That means the base cases. The base cases is earlier we say. The problem becomes small enough, I can right away return the answer. So that means the function simply return a result. That means the function terminated. So that's very important for the recursion function. Besides, you call itself, and also we need the base cases to terminate the function, so that we won't make our function become infinitely calling the function and cannot finish. So that we say here, usually the recursive function, typically they can divide into two conceptual pieces. So that one piece is the problem is solved by reaching the answer. And the other piece is keep breaking into the smaller problem. So this one, the other piece keep breaking into the smaller problem. That's our recursive code. So the other piece is, you see, the problem is simple enough, it just solved by itself. So that's we say the base cases. So whenever if we ask you to implement a recursive function, so you can typically to see, do you have these two steps? So the first example, we see the factorial example. So the factorial mean in math, that's if you have a non-negative integer, we can write an exclamation mark. So then if I write an exclamation mark, so then we say that's n factorial, right? The definition, that means start from 1, I multiply 2, 3, 4 until n. So those product together is n factorial. So like earlier we say that's non-negative number, right? So that's why you know 1 factorial is 1. But also we do have 0 factorial in math. Okay, so 0 factorial, be careful, it's not 0. 0 factorial actually is 1. So how can you solve the problem in Java? So if we say here that we write a static method, so then we call that factorial. Right, so n factorial, actually we will pass in the value n. So then we will return the value n factorial. So that's here we have one parameter is int and one parameter is your return value. So before we see the recursive function, yeah, of course you can solve in the while loop or for loop, right? So now the first thing I want you to pause this video. The first thing, can you write a function? Is we call factorial. You pass in the value x, you return the f factorial. I want you to write either for loop or while loop. Okay, after you finish, then you can continue the video. Wonderful. After you solve your problem, use the for loop or while loop to find the factorial. Let's think about. So this one, what you wrote, actually we say that's iterative factorial. So that's factorial. Actually, we can just using a for loop, right? So you can start from your product equal to 1. So then your product just need to in a loop to continue to multiply by n. So until your n reach the x, you finish. So that's one way to solve the problem. But now let's think about how to use the recursive factorial function. Like earlier we say, if you are a recursive function, you are a recursion problem, you can always break down your original problem into a similar, smaller problem. So right, n factorial, don't you agree, equal to n times n minus 1 factorial. Right, you see 5 factorial mean 5 times 4 factorial. So did you see here now? Right, so that's me here. If I write a function called factorial recursive, so then when I try to find n, actually that's me, n times n minus 1, I call my function again. On the other hand, we see, right, factorial 5. Don't you agree? 5 factorial equal to 5 times 4 factorial. So then again, 4 factorial equal to 4 times 3. So 3 factorial equal to 3 times 2 factorial. So then 2 equal to 1 factorial. But do I need to do 1? No, 1 just 1, right? So once I know here 1 factorial is equal to 1, so then I can return back the value, So then continue one by one, we find out 5 factorial is 120. So then we will see here, actually this one from here to here, we repeat to break down our problem into a smaller pieces. Then at the end, I reach my base cases. So that's my smallest pieces. So that's why now if I want to write a factorial recursive function, how should we do? So that's why here I want to remind you, whenever you start writing a recursive function, that's the characteristic you need to pay attention. Don't forget, we need the base cases. So most of the time in your recursion function, you can see either if-else statement or switch statement. So that's mean because in your recursion problem, they can either be the smallest piece, that's the base cases, or we break down into a smaller one. So that's why we need the choice which one it is. I need one at least or more base cases. So that's the simplest case. And later on, you need to see, do I have a recursion function code to reduce the original problem to a smaller one? So right, now when I want to write the recursive function, I still call that as factorial function, but that's become recursive. So remember, you need to think about when I have base cases. Right, so when my x equal to 1 or 0, right? So then that's my base cases. If x equal to 1 or x equal to 0, so I just finish my result. That's 1 factorial or 0 factorial equal to 1. Otherwise, you see I need to using the x to call the factorial function using the x minus 1. So this one actually is the x factorial. So that's why here you have your factorial function. Finish. Okay. Of course, this one we just simply to write. That's the C++ format. So that's why here I want you to go to the example for the compute factorial. So that's we will write a static factorial function. Okay, so that's our static function. So this factorial recursion function compared to your iterative factorial function, are they similar or different? Okay, so you can see compared with them. But here we will have a main function. So this main function will ask the user to enter a non-negative integer. Yeah, supposedly we should check. That should be a non-negative. So then we're just using the next int to get the value. Okay, so then here actually we just display all the factorial number. So that's why you will see here, if user entered 10, so that's why you have all the factorial display. Look fine, right? But the most important thing is, factorial function is better or iterative function is better? That we will discuss later. I want you to start thinking about that now. And also here, at least all the number of the function call time. You see here, if 0 is the passing value, 0 factorial actually only call factorial recursion function one time. 1, that's one time because they are base cases. But if 2, you see 2 factorial, I call the function one time. So then 2 need to reduce, become 2 times 1 factorial. So actually I call 2 times. So 3 factorial, I call 3 times. So then continue, you will see if I want to find 10 factorial. On the other hand, I need to call the factorial function 10 times. Totally, how many function call you have? Yeah, you have 56 function call. So the most important thing for the recursion function, we're using the function call to replace our iteration.